Well, this time we've got a thread repair job to do. And this is a cylinder head from a Morini 500. It's essentially the same head as the 350, but larger valves, ports, and a larger exhaust port thread. And this one, if we zoom in, we can see is not a happy thread. It's well stripped out. You can see a little bit of a bright ring down there at the lip of the port, and that's a little flat area. It's just got a little bit of machining on there. That back face is actually slightly conical where it seals onto the end of the pipe, and that's going to come in handy when we get it set up on the jig, or rather the fixture. And this is a pretty crude fixture that I made to do heads myself a number of years ago, and I've used it 3 or 4 times, and it just allows orienting the head in both axes so that we can get the port straight up and down. And I've just got it clamped down, and it wasn't as rigid as I might have liked, but it got the job done, and the way I've got it tied down now will hopefully be a little bit better than the way I was using it last time. So we'll get the head on and proceed from there. You can see I've got a bit of bar stop between the end of the spindle and that little flat seating that I pointed out previously, and I've been playing with the angles a little bit, and I can feel that this is contacting at the back edge more than the front, but you can't see any light. I can't even get a piece of paper in there, and I think that's about as good as I'm going to get it. For the rear angle, we've got the adjustable straps. For the front angle, there's a little bit of slop on the stud, so I've just clocked the angle, and now that I'm happy with that, I'll tighten these sleeve nuts that I made, and we'll lock it into position, and then the next job will be to centre up as best we can on what remains of that bore. I centred up by eye as well as I could, and then swapped to an edge finder, and then finally, once I had the boring head installed, I took some very light test cuts and tried to get what remained of the thread down in the base of the groove as even as possible. So I think we're centered up as well as we're going to be on this, and so the next thing to do is to take a light pass and set a depth stop, and then we'll proceed with boring this out. And what I'm going to be doing is taking it to a suitable tapping size and using this tap, which is a 48mm by 1.5mm pitch, and then I'll be making an insert that threads in with internal and external threads. I've taken a pass very carefully down as far as I want to go, because I don't want to come into contact with this surface, and looking at the groove width at the base there where the remaining thread is, that's pretty even. So I'm reasonably confident that I'm accurately on centre, certainly accurately enough So now we'll just start boring this out to size. The pre-tapping bore size for a metric thread can be very easily determined by subtracting the pitch from the diameter. So for example, an M10 by 1 thread, which is a metric fine thread, the tapping size would be 9mm. In the case of this 48 by 1.5, you get 46.5. So I set my calipers to 46.5, zeroed them, measured the hole size I've currently got, and switched into imperial measurements because my boring head is calibrated in thousandths of an inch. In fact, it will divide down lower than that. But this is the difference between the current size and the size I need. So now I'm confident about how much material I'll be taking out. Well, the final pass is done. We've come out on size. I've moved off centre to remove the boring head, and then we'll see if we can get the tap to work. Of course, having the DRO means it's easy to move off centre and then come right back on. Here's our tapping setup. If I zoom in, you should be able to read the spec on the tap. I was lucky enough to find this tap on eBay from Germany, and it whilst it was sold as used, it feels very sharp. It's obviously seen very little use. I ideally was wanting an M48 by 1mm thread, so I'd use slightly less depth on the OD of the insert, but this should work out just fine. I've got a centre mounted up in the quill, and the only tool I've got to turn this is the adjustable, but I think we'll get this done. I'll see if we can get the camera up on the tripod for this bit. It's just some duck oil, so I'm using one hand on the quill to keep the pressure on the centre, and then we'll turn the wrench with the other hand. Hard to avoid getting in the way. Seems to be cutting really nicely. Try swapping hands. Back of a bit to break the chips. And that's the tap bottomed out as far as it will go. Let's back out and have a look at the result. And that's looking really pretty good. I'll go handheld again and give you a close up. And there we go. That's it's looking pretty good to me. Well, I'm afraid I didn't get around to shooting any footage of machining the threaded insert, but you can see it in place here. So it's threaded internally and externally, the 1.5mm pitch, with the inside being an M45 to suit the nut. And in the end I decided to go with an engineering adhesive, and this one should be good to the kind of temperatures that we see. The heads don't run all that hot on Morinis. Their exhaust ports are both out in the breeze, so it should do the job. It's only got to stop the insert from turning when the exhaust nut is running and out. So I think it'll be fine. What I might consider doing in future is tracing down a 50mm tap, because on these later head castings, they use this beefed up casting on both the 350 and the 500 eventually. There is enough meat to go out to the 50mm, which would make for a thicker insert, which would leave open the possibility of welding. And again, because it's threaded, the weld only has to stop the insert turning. It doesn't actually have to try and hold it in. So overall I'm pretty pleased with the result. It's back on the fixture, and I'll be facing the insert back down to the original level here. But otherwise I think that's a successful job. And in the meantime I also did an insert for a 350 head. So you can see with the M42 thread on the 350 head, the insert's quite a bit more substantial, and there's enough room for a good alloy welder to get in there and get that welded. And whilst we've got the two heads alongside each other, I'll move this one round a bit. I'll see if I can show the difference. So you'll notice this surface has got a flat on it, and that's because it's sitting high enough to have been caught when this surface was machined. And if I line up, you can see that this edge sticks out beyond the fins, whereas again this area isn't machined, and the edge of the port is basically level with that finning. And this is a sort of interim head with the later style valve guides, or perhaps the valve guides have been changed. Because this head shows the earlier style valve guides which don't have the top hat section. They've got a groove and and a circlip. But once we machine that insert off, that's another job done.